So, hello dear students. We are on the 9th lecture of the Python course. So today we will talk much deeper into the using of objects in Python, object-oriented programming paradigm, and such things. So let's quickly remind what we have about objects in Python. So the first thing that we understood at the last lecture is that object itself as a concept is some encapsulation of data and methods or code inside the one instance. So we have object with object name that encapsulates two types of instances. First of all, it's a data, and we call it object attributes. And the code, we call it object methods. Also, we knew that in Python, we use classes to describe objects. So class is the blueprint how to create the instances of this class, and we call these instances objects. So the class is the full description of how to create an instance of this class, and we call this instance an object. And this object will have attributes and methods that was described in class, but of course we can add new attributes to the object itself, so to the instances. Let's start with the description of methods types. So before we talked only about regular method. So what does it mean? We have some class definition. Here is some class. Assume that we have class object. We have init function here to construct this object somehow. And we have a regular object, a regular method foo that takes the instance itself and some arguments. And do something. So we call this type of methods regular. Usual type of methods. So the thing is that we use this method with instance of the class. So inside your code, you have, for example, object 1 is equal to object. So we call the constructor with some arguments. And after that, we call object 1 dot foo. So we call method of the instance. So we call the method that use instance as argument, as self. But in Python, we can create 3 different type of methods, not only regular. So methods can be regular, class methods, and static methods. So now we must understand the difference between those three types of methods. Let's try to code something. So let's create a test. I can't write. So let's start to create some class. For example, class laboratory stuff. This is a person who work in laboratory. So we have our constructor. It takes self as argument and first name, last name as another arguments. Okay. So the regular method can be represented like a function, please get email. So we can return self dot formatted strings, string with self first name, dot self last name, add. Here we can have a class attribute, lab name equal add lab name dot edu. Okay, must rewrite here a little bit. So get email is a usual regular method that use self as an argument inside and return some kind of processing of the internal variables of the instance. So if we create an object, so for example, professor is equal to lab stuff and we can usually we have a smaller letter for the objects, so we can call the regular method from the instance, from the professor. And please print it. Lab name is not defined. Where? Line 10. Oh, of course. I must explicitly tell that this is a class variable. class name dot name of the attribute, and we can use the class attribute. So it will be common for all instances of this class. Yes, and we have full email for this object. Okay. What is the class method? First of all, to create class method, we can use a special notation called decorator with the name class method. And create a function. What we can do with the lab stuff. So, for example, return the main of the lab site. So, get URL, get lab URL. And if we use a class method type, so we must use first argument as a class itself. So there is special word CLS that we use as a standard for the class name. So for the object, for the instance of class, we use self, and for the class we use CLS. This is just a special word because we can't use class here, because class is a special word inside Python to define a new class. So instead, using class, we use CLS. And we can return, for example, lab name dot I don't know, edu. Or for example, we have lab name here in class and university. Okay, and how to use class method. Class method can be called from the class itself. So if we use regular methods from the instance of the class, the class method can be called from the class itself. So we have lab stuff class, and it has class method get lab URL. Okay, I forgot once again to explicitly tell that this is a variable from class lab stuff.
And could we write not lab stuff but CLS as explicitly?
Yes, thank you. Of course. This is for it, especially for it. Okay, so it worked. And static methods. So the static methods, you can think about them as functions inside the module. because static methods, it can create it using decorator static method. So the static method do not want any special arguments inside. So it's just a regular function, but it can be called from the class itself. So, for example, here, what we can for example, we can create function greet new staff member. And two arguments, not special, not instance, not class, but just name. For example, like this, print oh, actually, we can use here an object. For example, object of class staff, lab staff. So staff member, please print hello. Oh no, hello. Welcome to our lab. And here, staff member dot first name staff member dot last name. So this function doesn't need to know anything about class. So it just can be executed from this class. Maybe this function is not the best example, but for example, we can create a new static method that really has no arguments. For example, get maximum staff members without arguments, just return some number, for example, 200. And this static method can be executed from the class itself. Yes, it can. And we can execute it from the object. So because in object, we will try to find this method. So the interpreter will look inside the instance, inside the object professor, trying to find the method and get max staff members. And after that, it will turn on the method resolution order. So it looks first in the object. After that, it looks in the class from which this object is. After that, it looks to the parent classes. And after that, it looks into the parent of all objects. So it is a class called object. So in Python, we have a special class. So how I can show this? So this is Python. Let's create some object and new class. I don't know. Test object. Test object, and inside it has nothing. Okay, let's create a new instance of this. T equal test object. And we can use special help function T. So I forgot, have I told you about the help function, but this function shows the information about each object inside Python. So here we can see that test object has only two methods, the dict and weakref, and that's all. But I haven't seen the reference to the parent object. Okay. Maybe it isn't here. But the next theme today will be the inheritance, and we will see how methods are inherited to the childs of the parent objects. So let's finish with the methods types. So once again, we have three types of methods: regular, that use instances of the class inside as arguments; class methods that use class itself, not an instance; and static methods that are just functions that are defined inside the class. So the static methods are really special because they are not attributed to the instances and to the classes themselves. Okay, let's go to the inheritance theme. So,
can I ask you a question?
yes.
Should we use decorator, I mean Sabaka class method or static method to create this type of method? Or
once again,
should we use a static method? Sabaka static method.
Add
static method to create the concrete type of method, or it is not necessary?
Yes. So these decorators, they defined the type of the methods inside the class. So this is a syntax to create the methods that has not a regular type. So for the class method, we use decorator class method, and for static method, we use static method.
Can I ask questions too?
Yes.
Oh. To finish. Okay. This classification of methods is suitable for inbuilt object, or this is only for class case?
What do you call inbuilt objects? Because all objects are instances of some classes. So we have a class int, for example. So int is a class, and we call it actually a type. So type and class are somehow synonyms. And the 2, for example, number 2 is an object of class int. So
okay, I understand. And why we need this type of methods? What limits or benefits?
Okay, once again, here we use a regular method to operate with the attributes and another data inside the instance of the class, so inside the object. And the class method operates with the class attributes, with the so it works on the level of the blueprint, not a level of the particular built constructed object. So here we work with already constructed object. We have a self inside. So we work with this object. We work with a particular professor. And here we work with abstract lab stuff. So it can be any. So we just work with the blueprint with class method. And in static method, we do not want to know anything about instances and class blueprints. So we just have this method inside class. We just describe that we have it.
Okay, thank you.
I think in more examples we will find how to work with them, but of course the most time you work with object-oriented programming, you work with regular methods, because our goal is to operate with objects, to work with objects themselves. So the regular methods are much more popular, I don't know. So in most cases, we just need only regular methods. Okay. So let's proceed with inheritance. Inheritance in the object-oriented programming is one of the most powerful principles. So inheritance, as a biologist, I think you already know that what is inheritance. We have some attributes in the parent, and after we have the next generation, when we have childs, they inherit some attributes from parents. Maybe they change them somehow, but the sense of the inheritance is that a lot of properties from the previous generation, they stay in the next generation. So the same thing is recreated inside the object-oriented programming, not just in Python, but this is just a part of the paradigm. We use inheritance of classes to create new classes with the properties that was in the parents. Let's visualize it somehow. So we have parent class, and it has attribute 1, attribute 2, method 1, method 2. And we say that we have a child of this class. And this will be a child class. By default, after the inheritance, it will have the same attributes 1 and attribute 2, method 1, method 2. And of course, we can add here a new functional. We can add method 3. We can add attribute 3. we can change method 2 to be slightly different from method 2 from the parent. But the thing is that with inheritance, we do not need to reuse all the code from the parent class, because we can create 2 separate classes, P class and CH class, and describe all these methods line by line, and it will take a lot of time, it will take a lot of strings of codes. But with inheritance, we can have it for free. So think about it, we just copy all the data and code from the parent class inside our children class. And in this children class, we can modify all that we copied from the parent. So I think examples will be the best to understand. Just one moment, I want to turn on my charger. Okay, so here we have our lab staff class. Let's get rid of class methods, I think. Okay, we have 2 methods. We have init function, our constructor, and we have getEmail. And this can be any lab stuff. Let's create another class and call it, I don't know how we call it, laborant. Do we have such English word? Laborant? I think yes. And here we have a notation for inheritance. We have parentheses, and inside this parentheses we have a name of the parent class. So the parent class will be lab staff. And for now, we can, for example, do nothing in this class. Just inherit it from lab staff. And we can create laborant1 with the same constructor, with the first name and last name. And okay, please print us lab1 email. Yes, it works now, because in new class laborant, we have these class attributes. We have these class methods. We just inherit them for free. So we do not write here anything, because this inheritance notation do it for us. So we just, here we have all the previous attributes and methods without any additional code strings. So let's modify it somehow. For example, let's modify constructor, because now we have a specific lab staff, we have laborant, and for example, we want to init our laborant with first name, last name, and the project. So we have another argument project. So let it be the project on which our laborant works. And here, once again, we can create as it was in LabStaff our internal attributes. And after that, we create a new laborant project. I don't know, genome assembly. Please print us lab2 project. Oh, not lab2, sorry. Yes, it works. But this is not efficient way to do it, because inheritance in Python is much more powerful. Here, we can use a special word, super. So we can reuse the constructor from our parent using word super dot init. And here we must have arguments, first name and last name. Please pay attention. Here we do not insert any argument for the self of the parent class because super function here super is a function. Super do it for us. So actually I forgot. Maybe it's not a function. It's just an object. I think like this. Let's try it. So the thing is that here we do not specify the self argument. And after that, we must add that self.project. Please be project. Super init. Okay, let's go to the documentation. So Python init from super. Okay, it must be a function. I was right. So it's a function, it's not an object. Yes, now it works. So the special notation is use super function dot method from the parent. And in the parent method, we do not need to specify self or CLS in case of class method word. So super do it for us. And what it really does. So here we rerun the init constructor from the parent with creation of the self first name, self last name attributes. And after that, we add a specific attribute for the new class. And if in this toy example, we have just 2 attributes here, but in real work, we can have hundreds of attributes for the parent class, for example. And of course, it's better to use this inheritance notation to create a new class for new objects with somehow modified attributes and methods. Okay, so let's try to use help function now. So we have lab1 object. Please print us help of lab1. So what we see here, class laborant has init function that has first name, last name, and project arguments. And this is the order of method resolution. How Python interpreter will look for the method that we use with dot from the object of this class. So first of all, it will look at the class laborant. After that, it will look at the parent class labstaff. And after that, it will look in the parent of all objects in Python, built-in object. Okay, and we have only one method init here. Methods inherited from, okay. This is the method that described in the laborant class specifically. So this is a new init method. We have method inherited from labstaff. This is get email method. And another was inherited from labstaff is dict. Dict method that just show all the methods for the class. If you remember how it works, we can use dict. Oh, I think I want to delete this. It's not dict, sorry, dict method. We use dir function to show all inside. Yes. So these special double underscore methods, I think they are inherited from the parent of all objects. Okay. So what else we can say about inheritance? We have 2 special functions. So maybe I want to turn on the interactive Python. I can import from test import all. And now I have all classes here, so I can create lab1 is equal to Labyrinth, John Smith. And LabStuff 1. So there are some functions to check what is this object instance of some class or not, for example. So the first function have name is instance. Actually, I forgot the syntax. Python is instance. Okay, it gets as arguments objects and the class. So if we check 12 and int class, it says true. If we check 12 and float class, it says no. This 12 is not an instance of the float class. Let's go to our objects. So lab1, is it instance of Labyrinth? Yes. Is it instance of LabStuff? I remind that LabStuff is the parent class for the Labyrinth. Yes, Labyrinth is instance of LabStuff. Let's check LabStuff 1. Is it instance of LabStuff? Yes, of course. Is it instance of Labyrinth? No, because Labyrinth is the child of LabStuff. And there is another function that can check is some class a subclass of another. I think it's called is subclass. So here we have, for example, our Labyrinth class and LabStuff. Yes, the Labyrinth is subclass of LabStuff. Vice versa. No. And for example, how we call the built-in object? Maybe object? No. How to call the built-in object? Actually, I forgot how to do it. So this is not so important, but you must understand that all objects inside Python are inherited from the pattern for all classes. It calls just a built-in object. The built-in object is the parent for all classes and of course object that was derived from it.
But if we change all argument for child class in a new function, the object will still be part of
child
parent class.
Yes. We can change absolutely everything, but it presumes the inheritance connection. So the Python will know that there is some connection between the parent class and child class. And of course, they can be different at all positions. They can have all different attributes, all different methods, but we still will have this relation between them. One will be a parent and another will be a child. Actually, this not a method. This way to change the methods inside the child classes, we can call it. So I forgot. So we have encapsulation, inheritance, and really I forgot the word, how we call it. I just want to say evolution, but it's called in another way. Maybe we can just Google an object-oriented paradigm. And of course, this word will be there. Oh, of course, we called it polymorphism. So like in biology, we have different generations of objects, and we have polymorphism of methods and data inside. So your example with all data and methods that were changed inside, this is an extreme example when we have a polymorphism of all attributes inside, attributes and methods. So the overall thing is that this helps us not to rewrite a lot of code, to use subclasses, child classes, as modifications for the previously created classes. And there is another thing that we can use a lot, like architectural patterns and, for example, interfaces. So we can create classes that are not just a blueprint, but like how to call them. So in these classes, we want to guarantee that these that objects that will be inherited from these classes will have some properties, specific properties, and we call such classes interfaces. So it's a paradigm not from Python. There are a lot of such stuff in Java, for example. So in Python, we have no such classes interface, but we can imagine them. So interface is a class where we guarantee something for the programmers that will inherit their classes from us. For example, we can create a class printable that will have a method to print some feature inside, not some feature, to print the class. So it will have str method. And we can call it printable. So for example, if lab stuff will have str something. Return some string. So we can call, for example, this class printable and then inherit our class from printable, and it will have str method. We can create some class with iter method, and this is our next theme, and we can call this class iterable. So all things that I said before about iterable objects, so just think about it. Iterable objects, they all have __ iter method. They are iterable because we have this guaranteed method inside. So it's not about Python, it's just about programming, but look here. We can use linguistic, the human linguistic, to divide different instances inside the programming languages. So when we talk about functions, some functions, we can use verbs, because function is literally the set of different data processing steps. So to function, we call please do something. We can use verbs for function. For objects and classes, we use nouns because it's instance of something. So this is something. And for interfaces, we can use adjectives. So this is some kind. For example, it is iterable, it is printable, it is mutable, and other things. So in Python, we can emulate interfaces using classes. But of course, there are not such construction as interface like in Java. Why I'm talking about it? So for you to understand why we use the object-oriented paradigm, because we want to create the abstract model of some domain field. For example, in our toy case, we try to model some laboratory with employees to have their surnames, names, emails, and other things. Okay. So once again, what we have talked about today, that was from the previous lecture. How to erase? From the previous lecture, it was encapsulation, where we combine the data and code inside one, not instance, but in one block of code. So this block of code called class. And the next thing is inheritance, when we can create the hierarchy of the classes, which can help us to have for free all previous data and code. And polymorphism as the way to change methods. from the parents to create a new classes with a new functional. Okay, let's go to the last theme for today. I want to show you what the iterable objects really are. So before we talked a lot about iterable objects as some polymers that consist of monomers, and we can iterate over it one by one. So let's write some iterable objects and look how it works. Let's create a new class called myRange. If you remember that we have range function inside Python, this is a generator of the arithmetic progression. So let's try to create myRange. Def init self start and end. So you remember that each iterable object must have iter method. But what is the iter method? We do not talk about it, so didn't talk about it. Iter method is a specific method that returns iterator, and there is a difference. So let's write two words. Iterable object must have underscore underscore iter method. Actually, there is a shortcut for underscore underscore calling convention, so we can call it dunder. But I prefer to use just iter. So this is dunder iter, but we can call it iter. So iterable object must have this method. Iterator, this is an object and it must have underscore underscore next method. They can be the same object, but can not to be. You must understand that iterator and iterable object, they are not the same things. The iterator must have a next method and iterable object must have iter. And these special iter methods, it returns iterator. So this method returns a new object called iterator. So each our iterable can return iterator. How we can show it? For example, we know that list is an iterable object, but list is not iterator. Let's create some list. L1 is equal 1, 2, 3. Type L1 is list. And we can iterate over it. For element in L1, please print element. Yes, we can iterate our it. It means that list is an iterable object. But can we call, for example, next from list? No, because list is not an iterator. Okay, how we can create iterator from list? We can say, please execute your internal iter method. ETR is equal. So the type of ETR will be list iterator. And here we can call the next function before we have a stop iteration error. So let's return to our myRange function. It has iter method. It is iterable, so it must return some iterator. But let's return ourselves. So let's return the same object. It means that myRange must be both the iterable object and iterator. To be iterator, it must have a next method. So what does next method? It returns the next value from the iterable object, and it knows the position where we now is. And if the position is more than length of the iterable object, we must raise this stop iteration error. So let's do it. Maybe it's better to call this value as, for example, value. So if value, if self value is more or equal than end, then self dot end, please raise stop iteration. This is a notation to raise error. We will talk about it when we will have a lecture about errors. But for now, just understand that we raise the stop iteration error when our internal value becomes more than our end. And else, please current equals self dot value increment by 1 and return current. Okay, let's create myRange. So mr is equal myRange. For example, from 1 to 10. And please print. Oh, no, not like this. For element in my range. Oh, no. In mr, please print element. Stop iteration is not defined. Why not? Stop.
T is missing.
Okay, thank you. Stop iteration. Iteration. Okay, thank you. Okay, here we are. We created an iterable object, but we talked that it is not only iterable, it is an iterator itself, because it have a next method. So what we can do, we can create an iterator that is equal to my range iter, and then maybe from 1 to 3, and please print next iter, print next iter, print next iter, and once again. So we assume that here it will print 1, here 2, here. Oh, here we will have a stop iteration error actually, because it is from 1 and not from 0. Okay, let's check. Okay, 1, 2, and stop iteration was raised. Actually, it works pretty well. We can modify it. For example, range has not only start and end, it has a step that is by default equal to 1. And here we have 2 options. We have 3 options. Maybe we must check it here. If step is equal to 0, please raise exception. And in our next function, we can check if step less than 0, then if self value less or equal, if self value less or equal and raise stop operation, else current is equal to self value is equal I want to create some more clever condition, because this looks like not so good. Maybe like this. If what's going on? If self.step more than 0 and self value more equal the self end, or self dot step is less than 0 and self dot value self dot end. Please raise stop iteration. In other case, current is equal self value plus equal self dot step and return current. Okay. Let's try different cases. So first, for element in my range 1, 5. Okay, 120 step 3 print element print, and for element in my range 21 minus 3. So here we have from 1 to 20 with step 3. Here we have from 20 to 1 with step minus 3. And that's all. This is how iterable object looks inside. So inside each iterable object, we have an iter method that return iterator. We can create a new class iterator for this. So in some cases, we have another class my range iterator that is created specifically to be returned from here. But in this case of this very simple object, my range, we can return the object itself because it has a next method. And if we have a next method, we are an iterator class. And inside iterator, we describe what we return on each iteration and when we raise a stop iteration. The thing is that we can create a class without this stop iteration. For example, class infinite squares. So let it be without any arguments in it. So we can delete all of this. When we have when we return iterator, we return itself, and our next method will be please. Okay, in init, I want to create self.current equal 1. Please return out equal self.current in square. self.current increment by 1 and please return out. And we can use it as a infinite sequence of squares. If we create a for loop for this, it will be really infinite. Infinite squares. If I run this code now, it will never stop. I think I can handle it with Ctrl+C keys. No such file. Why? Look here, the infinite numbers, the infinite squares. And we can use it, for example, with some condition. So if element less than 10 in, I don't know, in 10, please print element. And we stop, I think. No, maybe a 10 in 10. It's really huge number. 1, 2, 3, 4, 5.
Maybe you need to add break there.
Yes, of course. Of course, because the cycle will continue. Yes, yes. Else. Yes. And now it stops. So we can create the object with a infinite number of iterable monomers. I don't know how we call them. So we can create infinite sequence inside the Python and break by a condition, for example. Okay, the last few words about generators. I have 5 minutes, I think. So the iterators and iterable objects are classes, but in Python we have a special syntaxes to create generators. They work just the same like an iterators, but it has another syntax. We can create them as functions. So let's create the same function with an infinite series. What's going on? Okay, with infinite series of squares. If we have function, we must call it from the lowercase. Infinite squares. And here we use a special word yield instead of return. So please yield us. Maybe we can have x equal 1 by default. So please start from x. Yield x squared. And after that, please x plus equal 1. And for element in infinite squares, let's start from 2, for example. Please, if element less than 10 in, I don't know, in 5th, print element, else break. Only 4? Why only 4? Okay, let's use Python in interactive mode from test. Please import all. Infinite squares from 2. SQRE in infinite. Generator object. Okay. If we create for loop for element in print element, just 4. Why just 4?
Maybe we need some sort of recursion function. Infinite squares.
Once again, the thing is that yield is a special word to create a generator object that will remember its state and return to this state in next iteration. So it's create the object that is really looks like an iterator. Okay, why we have these only 4? Let's look to the Python. Python generators. Okay, I understand now. So the cycle must be inside the generator function, because now it will execute it only once. And if we want a real generator, we must have here a cycle. So while true, please yield us x in square and increase x. Okay, this will be a infinite generator. Yes. So we stop only when element will more than 10 in fifths. So where we can use generators? Of course, you remember, actually I'm out of time, but please guys, 2 minutes. We have these notations for list comprehensions, x for something in range, something 1 to 4. This create a list, but if we have such kind of parentheses, this the generator. It returns the same object like as a function that has yield inside. And I know that in discrete math you already learn how to generate, for example, different combinatorics objects. And you can use such generator functions to generate your objects of interests. And what is the purpose of generators? I already told you about range function. So you can yield a value without storing, without holding the whole bunch of numbers in your memory. So you just yield it in each iteration. And the purpose is to create such generators, not to use memory, but instead generate values only when you need them. Okay, I must finish for now, but please, if you have questions, please ask. Okay. So, but anyway, if you have additional questions, please ask it in chat and I will answer them when I will have a time. And I don't forget about your homeworks. I just haven't enough time to create it, but I will write you as soon as possible. So thank you for today. Goodbye, guys. Have a good day.
Thank you.
Bye.
Goodbye.
Thank you. Goodbye.
Thank you. Bye.